Okay, good morning, everyone. So, I think your exercise. I think I have works one here. I haven't give all the answers, but um, I just want to review a little bit on chapter one here, which you have a right angle frame in this problem, chapter 1.4, number 16. So first is we are going to draw the free body diagram and pull off all the reaction forces, okay, all the reaction forces, and then basically what you need to do in chapter 1, every step, every procedure after you draw the free body diagram is taking the equilibrium. By taking equilibrium means that you take the force on the x-axis, y-axis, and the moment. Okay? And after all that, you will get everything that perhaps the question asks. Okay? For example, this question is asking on the support reaction, which is this. And then the second question is about the internal resultants here. So it's asking the internal reactions or internal resultants on the C. Okay, so this is C, so we cut the C, we cut open, and then we draw a new free body diagram, which is this. We draw the new one, and then based on what we have, since we have this AY previously on the previous question, then we can use this value to compute the internal result, which is the moment at C, the axial force at C, and then the shear force at C. Which basically you just need to take the sigma moment at C equals 0, and then you can bring everything out and calculate the moment here. And after you get the moment, then you can also get the sigma force x and y to get the FC and the VC, the axial force or the normal force and the shear force. So I think most of the question on chapter 1 is basically the procedure is just like that. That is needed for at least your quiz will be majority will be about the chapter 1. Okay? I think just chapter 1 to make it easier to compute, okay? And just chapter 2 and 3 maybe for focus on midterm, okay? So that's chapter 1 review, and you could do the same thing here, okay? So I hope your works well with the other number like this one. Please works on this number and this also, okay? So this is added the force distributions here. Okay. So I hope you get both calculations. And then I also did this. This is for chapter 2. Basically, at the first part or the early chapter 2, we need to measure the centroid. I hope you know how to measure this length, the R, okay, the YR, okay. To measure the length, we need to measure like if you learn physics, you need to know how to measure the center of mass, right? Center of mass. Like how much is it? Like, is it in the middle? Okay. And then you need to calculate the whole masses, right? So basically, the idea is you have this size like this, the shape like this. The idea is the geometrical shape that is easier to calculate is the rectangle, right? So basically, as mentioned within the structure, it has this T shape, which we can divide by 2. We can divide by this 2 rectangular shape, okay? And let's say we take this as 1 and that part is 2. So basically, this YR, okay, if we multiply with the whole area, is equal to the A1, the area 1, multiply with the half of the its height, because that is the center of mass or center of area for the rectangle 1 is here, right? So we multiply that plus the second area here for the second shape, which is located the half part of the height, right? Okay, that's why I'm calculating this. But we need to measure the height from the ground, okay? And then we take the equation. So the YR, we just need to divide by the whole area, the total area, and we get the YR is this, okay? This is very basic, and I think in physics and also in the statics, you learn about this or not? Find central.
We didn't take statics.
Ah, really? Statics? Physics?
Yeah.
Okay, physics. Okay, I hope you still remember how, okay? So basically, the idea is just playing with the geometry. Usually geometric shape are either rectangle or triangle, okay? Just both of those structures. So I would like just to continue, and you can try this one. This is also the similar questions. We need to take the centroid, okay? We need to take centroid and then calculate, okay? And then calculate the magnitude of the tensile stress, okay? Now I would like to, I would like to start with this, okay? This example. Okay, you could try. Maybe I'll give you a couple minutes just to look at the questions and maybe trying to. I hope you are familiar with drawing the schematics diagram or drawing the free body diagram. So basically, that is the first steps in our calculation. And later, I will put this in our the lecture exercise notes in the Moodle. So please check. Some of the question I try to answer and review. Some still in blank. It means that I hope you work on that. But every week I will fill in the answer. Okay, I will fill in the answer. So I hope you works with that. Okay, I hope you works with that. Okay. So you have a rod and you have a force acting on point Z. It's a compressive. But we need to know the stresses. We need to know the stresses in AB and also in BC. It means that we take the free body diagram into two parts, okay? Because we have. So if you see the diagram, you see that the part is obviously has two, which means that first you can imagine the second part, and then you can draw the first part. So you can make two diagrams. And since it is started from the second part, because that's the external forces are coming in, it means that we can start from that point of view, and then this second part will be, so we can start from here, so we can cut here, and it's the other diagram is we cut here, the whole thing here. So we can have this, the first structure can be cut, okay? So perhaps we can draw maybe let me just copy this, okay, to make it clear, okay. And then let me take the crop. Okay, now this is the first part, and I make it similar. So we cut open this, and when we cut open the first one, then we are going to have this as our F1. Okay, so we cut open here, and then the same thing, copy. And let me take maybe here. The second part is this. And this is defined as the F2. Okay. Okay, now before we continue, because this is a cylinder, okay? This is a cylinder, right? And they have diameters, different diameters. I think we can just compute the diameters in for the area. Okay, so area 1, or let me write, diameter 1 is 60 millimeter. Diameter 2 is 50. Okay, so I check with my calculator to check whether the answer is correct or no. So using the diameter, we can write this will be 60 millimeters squared, but now it's over 4, right? So pi multiply with 60, it's 28, 27.4. This is 19, I think it's correct. 49. And then we need to know how much forces are needed. So taking the sigma force equals 0 for the axial direction, because there is no vertical direction. So F1 equal PB minus 50 kilonewton. Or PB is 100. Let me just write that directly. 100 kilonewton minus 50 kilonewton. And then the F2 is negative 50. Okay. And then basically, the sigma 1 is F1 divided A1. I think it's quite easy, right? I think you can just divide. I think you can do by yourself. I think this is too easy, so I think I get the wrong example. Maybe, let me check the other example. Okay, I think this one is too simple. How about this one? Okay, number 2.29. Okay. So I hope you could see the idea here. And the question is a little bit not straightforward, but it's like analysis questions. So first is the question is asking if the load located at x equal 1 meter, what are the stresses sigma 1a and sigma 2a in the respective hanger roads, which means this x here, if this x is 1 meter. So we need to know all the stresses that is going from these two point A and B. We need to know the reaction forces or the stresses for that both points. So again, the idea so the weight is basically weightless. So we need just to we need to observe only for the external force 60 kilonewton. So let me draw the diagram. So this will be so this is for number A. So number A says that at the respective rod, the sigma will be 1A, the left, and the second one is sigma 2A. So let me state that there will be, assuming that there will be a force here, which we name F1A, okay, based on the informations. And then there are also another one here, which is the F2A. And then, okay, we name this is A, this is B, and then there will be a C around here, which is we have the P, the external force, which is 60 kilonewton. For number A, the X is 1 meter. So let me just draw here. Or maybe to get into all definitions, let me just copy this. Let me copy and make here. And this will be B. So for A, the length total is 3 meter, and this is 1 meter. So we have the other part is 2 meter. So this will be 2 meter. Okay, so I think we get everything for A. And if you want to see B, we could just erase this A into B. This is 1B, 2B. And then it's asking the distance. So it's asking this X. So this is a two different question. And this is the typical question that might come up in your lecture or exam. And then that will be 3 minus X. And then okay, so for B, the sigma later assumption will be the same. So sigma 2 equals sigma 1 for B. But let's start with A first. Okay, let's start with A. So this is for A. So when x is 1 meter, then we take, let me just write one by one here, equilibrium, just like usual. All the sigma m, sigma f, we write 0 like that. Okay. Especially for the moment, we need to take the moment at the first step. Because if we choose sigma f, what we can get? Nothing, right? Because we still need to know what this is. But if we take the sigma moment first, we can take perspective on B or A. Okay, if you take perspective here, this means that you are going to take the moment, for example, 60 kilometers is going there, and this going there. Only that, and you will get this, right? Okay, and you can solve that using the sigma f. Okay. So you can choose sigma moment A or B, the same, but you will have a little different calculations, but similar calculations. Okay, so not too complicated. Okay, so let's say we take sigma moment A, let's say, and then we state that every clockwise is positive. It depends on you. Okay, you can state that the counterclockwise positive or clockwise positive, same. The assumption is the same because every time you take that and you are working with a consistent process, it should be the same result. Okay. Okay, now taking the A as 0, so we take, so this is number A. Okay. So we take the 60 kilonewton multiply with 1 meter, and then minus F2A multiply with 3 meter equals 0. So F2A is 60 kilonewton meter divided by 3, which is 20 kilonewton. So from sigma f we get, let me write here, sigma f equals 0. So F1A plus F2A equal 60 kilonewton. So F1A, when F2A is 20, then F1A is 60 minus 20 is equal 40 kilonewton. Okay? So we get everything here for number A. And then for number B, oh, we have not done yet. I forgot to calculate the stress. Okay, I forgot to compute the area. So I think at the beginning we should compute first the area to make it easy so that you can just type in your calculators easily. So area is, what is the diameter? 25 and 20. Okay, or I think maybe going direct into the solutions is not a bad way. So I think let me just write here going to that way, and then write the sigma directly. So sigma 1A is F1A divide A1. The diameter 1 is 25 millimeter diameter. So I will write the F is 40 kilonewton, and this will be pi 25 millimeters squared, and it's divided by 4, but I will write 4 here. Okay, the same, right? In mathematics, we can do that. So let me check my calculations. Is it correct or no? it's 0.081 in kilo, but I would like to take 1,000 to make it Newton. So we are going to have multiply with 1,000. It's 81.49 megapascal. Okay, so megapascal is Newton per millimeter squared. Okay, so we get the second one, the same idea, but now the diameter is 20 and the kilonewton is 20 kilonewton. It's 63.66 megapascal. Okay. Now we get everything on A. For number B, we are going to have the same results. But remember for B that the sigma will be equal, which means that the F1 over A1 equal F2 over A2. And you will have an equation that you will see some canceling with each other. And basically, all what you need is the equilibrium again. We make the equilibrium based on now this picture for number B. So we want to know the distance. So again, the same sigma moment, let's say sigma moment on A or on B. Let's say a sigma moment on B. So we have 3 minus x, but I think it's not good, but 3 minus x. I think it's A because we have this and that. So we get directly x. Right? So I think just sigma moment A. I think that will be better. So sigma moment at A, and again, that is positive there. So we have 60x and then minus F2B 3 equals 0. But I think, since we want to have this, and since the F1 and F2, we need to compute that in our system, then I think it's better to take the moment on C because we get the F1 and F2 directly, and we have some equation that we can plug into our equation. I hope you get my idea. You still can do something on here, but I think you need another moment for moment on B to get the F1B, right? But I want to have everything, I want to get F1B and F2B in one equation directly. So I think better to count here because I get this and I get this. Because our concern is not the F anymore. Our concern is we want to find this F. Okay? And this F1 and F2, we can have substitution here. So we can get everything at the same time. So let me do it again here. And let me take C. But you could always try moment A and moment B. It should be the same result. It should be the same result. But I want to get the shortest path as possible. So let's say this is going to be F1bx. And then minus F2b, 3 minus x equals 0. And then the sigma f equals 0, which means that F1b plus F2b is equal 60 kilonewton. So we get everything now, the relations between F1b and F2b. So F1b we can substitute 60 minus F2b, and then from here we could get that the F1 BA2 equal F2 BA1, okay? So we can solve the equation simultaneously. So this will be, so this is basically, we can solve this. So pi, this is what, 25. Okay, so this will be cancel pi. So we have what? 25 millimeters squared. So so we have F1B 625, F2B 400. So we can have, this is 25, this is 16. So F1B is 16 over 25 F2B. And we can input that in our system. So F1B, or maybe F2B, is to make it easier to calculate with the other one. So I will substitute this to here. I will get the F1B. So F1B is 60 minus 25 over 16 F1B. So the number is not good. So 41 over 16 F1B is 60. So what is that? 60 multiply with 16 divide 1. 23. So F1B is 23, 414. And then bring everything back to this equation here, and then you get the F2B, so minus 60. So F2B is, so let me write here that F2B is 36.585. This is kilonewton. Forgot to write the notation, the unit. Okay, so F1B, we get F1B, we get F2B, and you can get the stress. You can define by each area. And then this F1B and F2B can be put into the moment equations. Okay. You can put in the moment equations. F1B and F2B, so we get the answer. I didn't put everything, but I think you get the idea, right? You can just put into the calculator because it's on with all decimals. Okay. Okay, any questions? Any questions first? I think this is quite straightforward, but you need to understand the questions one by one. Because if you don't understand like how to do this part, and assuming that, so I think to help you with the practice, or perhaps during the exam, any quiz or any exam that we might encounter. Sometimes the questions maybe they are too long and maybe sometimes confusing, but if you're familiar with the exercise, I think it would not be a problem. But if somehow during the examinations you feel that the question is not too straightforward or a little bit confusing, so you just let me know. Okay? Let me know during the exam. I will try my best to explain what is the question about, and even maybe giving you a clue, because sometimes the condition, okay, to be honest, sometimes it's easy, but to write the whole thing is too long. Okay? I mean, practically it's too long, so it takes time. So estimations, for example, like quiz, like last year, I think I had optimism, so I give a little bit questions, but then I realized that it takes time to write. Although the question is easy, but it takes time to write. So I think for our quiz, I will prepare only 2 questions. So each question's estimation is 20 to 30 minutes, each question. Well, if you are like no problem in calculations, I think 15 could be okay. Should be okay. And then the rest is maybe you can think like if the question is needed some analysis, I think you still have that time for thinking. Okay, maybe one more question. Maybe one more question before we end our class. And maybe not completely solved, but I think I can give some idea. Maybe here, okay. This is similar to what we have before. 2 to 6. 2 to 6 is the same rod, I think. Or do you want to have, because your quiz is chapter 1, how about we go back to chapter 1? It's okay? Chapter 1. Okay, how about this one? You have frame ABE, and again the question is giving you some clue what might happen here, the internal forces, so you can use this as your reference. So you have the frame and it's giving you an angle here, and then we need to determine first its reaction at this E and B, on the E, and B determine the resultant at C, and then what else? I think that's the question. So I think we can start. We can start to, first is to draw. Let me check, is it the same question that we did? Okay, now I will try my best to draw here. So this will be the frame. So this will be A. Although it's not straight line, but I think still okay. This is E. And E is just a fixed point. We can just imagine this is going to be that way. And how you assume the reaction is up to you. You can assume downward, left, right, it's okay. The results, sometimes maybe it can be positive, negative, it's still okay. And then you have D, this is around here, this is D. And then you have A like that, and this should be a roller. And then you have some forces here. P. Okay, I'm not sure how many P. Oh, P is 1 kilonewton. And then you have an angle here. And then you have this is B. This is B. And B is having a roller, right? Roller pin. So we have only horizontal there, okay? Because we can assume that it can move vertically. So we can imagine that this is Bx. And then this is C, and we have the length here, 200 and 100 is 300 millimeter, and this will be 100. So equilibrium, we can take all the, so P is equal EY, right? Or EY is 1 kilonewton. So we get EY. And then what else? I think we can go for the sigma moment directly. Sigma moment. And we would like to know the E, right? We would like to know the E. So moment for E, since we have kilonewton here, already know, then I think it's better to get into B. So that E goes here and it goes there, right? So we can write sigma moment at B equals 0. So well, let me write that as a reference. So it's positive, so this will be 400. And then minus, it's going to the left, 1 kilonewton and 4. Oh, wait. The distance here, I forgot to mention. This is, oh, okay, wait. You need to be careful here. This is 400, right? But we have additional 50 millimeter. And because the forces is at this end, so we need to add 50. So not 400, but 450, okay? So we need to add another distance here. I almost got it wrong. So this will be 50 millimeters. So this should be 400 plus 50. So 450. Okay, be careful on that. Okay, and then this will be 0. And then you can compute that and get E. So you get EX and EY, and then the second part is internal resultant. So to get the internal resultant, we do need the theta for some conversion. So let me go here to give you another diagram. So let me make it small. So we cut here. So imagine this is C. We get this is shear force. Oh, yeah, let me just make it like that. So this should be going over there. Make a similar opposite direction of the nodes. So this will be VC, FC, and the moment C. This will be 100, and this will be 200. So this will be C, the point C, right? And then this will be point D. And we have the stresses going here. And then we have the angle. Okay, now we need to find the angle first. We need to find the angle first by taking this, by taking here. So this will be that, okay, triangle. So find theta, and then we are going to use theta to find this. Okay. So this will be using the theta, taking the sigma fx equals 0, sigma fy equals 0, and to get easier, oh, this is E, sorry, sigma m at C equals 0. Okay, and then basically that is all you need. This is EY, this is EX, and then everything already in distance. So as long as you get the theta, you will get everything right. So this will be P equal 1 kilonewton according to the questions, but it has a direction here which we need to have two x, y directions using the theta. And then based on that, we can compute everything. Okay. So I think that is for today's class.